Press the bell icon on the YouTube app and never miss another update.
Next question. Let capital A equal to the set of 1, 2, 3, 4, 5, 6. Insert the appropriate symbol belongs to. Already I said how to read and what is the meaning of belongs to or not belongs to. So under simple meaning, belong means is in. This is the simple meaning. Not belongs to means is not in. Read just like that. Understand just like that. It is the simple meaning. So I am asking one simple question. 5. Is 5 in capital A? Yes. Yes. So write belongs to like that. Next, second element, 8. Is 8 in capital A? This is our question. Answer, no. 8 is not there. Therefore, no means not belong to. It is not. Is not. 8, our answer is 8 is not in capital A. Here 5 is in capital A. You come here, 0. 0 is 0 in capital A? No. You see there. So therefore 0 is not in capital A. Is not in capital A. Therefore it is not belongs to. Next 4. 4 is there. It is means is 4 in capital A? Yes. Answer is yes. So therefore complete answer 4 is in capital A. Is in. Is in means belongs to. Similarly 2. Is 2 in capital A? Yes. It is belongs to. 10. No. No means not belongs to. So simple meaning belongs to means is in. Not belongs to means is not in. That's all. Write the following sets in the roster form. In the roster form. Roster form means already I said in the synopsis. Roster form means very clear form. Means we have to write very clearly all the elements satisfying the given property. Of course, it is in set builder form. Okay, number 1. Answers. Number 1. Capital A is equal to this one. Capital A is equal to the set of x is an integer between -3 and 7. Listen, first take real line. Actually, this is the graph. This is the graph. 0, 1, 2, let it be 3, 4, 5, 6, 7, 8 and so on up to infinity. Next, negative side. -1, -2, -3, -4 and so on up to -infinity. Okay, next. -3 less than x less than 7 means x is between -3 and 7. Between means already I said between means except -3 and except last number 7. This is called between -3 to 7. Okay. First condition. This is the first condition. What is the second condition? It should be integer. Means in this area how many integers are there and what are the integers? Integer. Is it -2 integer? Yes, negative integer. It is integer. -1 integer, 0 integer, 1 integer, 2 integer, 3 integer, 4 integer, 5 integer, 6 integer. We should not take 7 because he said between. We should not minus 3 because he said between. Understand? This is the meaning of between. So very clearly integers minus 2, minus 1, 0, 1, 2, 3, 4, 5 and 6 only, but not 7. Okay, answer is over. Now I wish to explain about the integers. You come here. Just some synopsis of integer. Integer means, for example, 4.73. Let us consider this number. So point dot. So for dot it is the left side. This one is right side. So therefore it is called integer part. It is called integer part. It is called integer part. Next, right side of a point means this one. It is decimal part. It is a decimal part. It is a decimal part. Okay. Next, integer. Actually, 0 is called integer. 0 is integer. 1 integer. 0.001. It is not integer. It is not integer. 1, 2, 3 is an integer, not 3 pointer. Means the number which do not contain the decimal part. It is called the integer. You tell me in 4.73, decimal part is there. Yes. What is the decimal part? 73. Next, which one is the integer part? 4. So 0. I wrote 0. Am I wrote like that? 0.01 like that? No. No decimal part there. Therefore, it contains only 0. Therefore, it is the integer. Next, I wrote 1. Am I wrote 1.75 just like that? No, no. So, I wrote only this part. This part. So, it is integer. It is integer. It is integer. Similarly, 4, 5 and so on. In mathematics, and so on means infinity. Up to infinity. Up to infinity. Infinity means its notation like that. It is not a number. It is the symbol. It is the concept. Just that's all. It is not a number. So and so on up to infinity. Next, negative side. Minus 1. Am I wrote minus 1.37? If yes, it is not integer. It is decimal number. So this part is decimal part. This part is integer part. So therefore, I wrote only minus 1. So minus 1 is integer. Next, minus 2, minus 3, just like that. So these are all integers. Simply we can write it as the set of 0, 1, 2, 3, 4 and so on. Next, negative side, minus 1, minus 2, minus 3 and so on. These are all negative integers. These are all positive integers. Okay, this is set of. This is the set of integers. Set of integers. Set of integers. It is simply denoted by Z. It is simply denoted by Z. It is something basic mathematics. So, also denoted by capital I. Capital I. So, therefore, this is the set of integers. The set of integers is denoted by capital Z or capital I. Next, positive integers. Positive integers means set of positive integers. Actually, set of positive integers is represented by Z plus. On the head we write plus. This stands for set of positive integers. That is equal to set of positive means 1, 2, 3, 4, 5, 6 and so on. just like that. Sir, you wrote only up to 6, only 6 elements are there. No, I wrote the notation dash means read as and so on, means such numbers are up to infinity. How many are there? Infinite numbers are there. This is called Z plus, set of positive integers, or simply it is denoted by I plus. I plus means set of positive integers. Next, set of negative integers. Set of negative integers. Actually, it is denoted by Z minus. Is it visible? Z minus, that is equal to -1, -2, -3, -4 and so on. Of course, it is also denoted by I minus, Z minus, set of all negative integers, -1, -2, -3, -4 and so on, just like that. Z plus means 1, 2, 3, 4, 5, 6 and so on. Find out. Sir, where is 0? No. 0 is neither Z plus nor Z minus. Mind it. 0, note. 0 is neither Z plus nor Z minus. But 0 is belongs to integer set. This is something about positive integer, negative integer and set of integers. You come here. Next, this is over. Next, second question is also in terms of set builder form. So we have to write it as in terms of roster form. So capital B, number 2, capital B is equal to x is what? X is a natural number less than 6. So natural numbers, already I said about the natural numbers, something about natural numbers. Natural numbers means counting numbers. Natural numbers means counting numbers. Counting numbers starting with 1, not with 0. So therefore, less than 6 means 1, 2, 3, 4, 5. That's all. Not 6. He said less than 6. Less than 6. X is natural number. Means what? On the real line, means in the graph or on the x-axis, suppose it is 1, 2, 3, 4, 5, 6, 7, just like that. Natural numbers are positive integers are there. Less than 6 means in this area. So in this area means 0 is not a natural number. So 1 to 6 means 5 is the natural number, 4 is the natural number, 3 is the natural number, 2 is the natural number, 1 is the natural number. So therefore the set of 1, 2, 3, 4, 5. This is capital B. Next, let us consider third question. Number 3. Okay. The set of C is the set of X such that X is 2 digits natural number, so that sum of the digits is 8. Sum of the digits is 8. You see here. First we will write 2-digit number. 2-digit number. 2-digit number means this is just like that. Of course it is unit place and this one is tens place. So first I will give the list of 2-digit numbers so that its sum is 8. So 0, I will start with 0. 0 plus 8 is equal to 0 plus 8 is equal to 8. Okay. Next, 1 plus 7. 1 plus 7 is also 8. Next, 2, 6. 2 plus 6 is also 8. 3 plus 5. 3 plus 5 is also 8. Next, 4 plus 4. 4 plus 4 is also 8. Next, 5, 3. 5 plus 3 is 8. Next, 6, 2. 6 plus 2 is equal to 8. Next 7 1. 7 1. 7 plus 1 is also 8. Next 8 0. 8 plus 0 is also 8. So remember 0 8. 0 8 means only 8. 0 8 1 7 2 6 3 5 4 4 5 3 6 2 7 1 8 0. First, all are natural numbers. First condition is natural numbers. Okay, 2 digits, sum 8. So how many conditions are there? Number 1, it should be 2-digit number. So next condition is it should be natural number. Next, third one is its sum means 8. Its sum should be 8. So we have to find the numbers so that 3 conditions are satisfied. So here 0 8. 0 8 means it is only 8, but it is not 2-digit number. One condition is failed. It is 2-digit number. It is also 2-digit number. 2-digit number. 2-digit number. 2 digits are there. 2 digits are there. 2 digits are there. 2 digits are there. Next, last condition. Sum of the digits must be equal to 8. 1 plus 7, 8. 2 plus 6, 8. 8, 8, 8, 8, 8, 8. So therefore, capital C is equal to 1 7 2 6 2 6 3 5 3 5 4 4 5 3 6 2 7 1 and 8 0. So therefore, it contains 1 2 3 4 5 6 7 8 elements are there. Next, D. Number 4. D. X is a prime number which is divisor of 60. Divisor of 60 means I am asking one simple question. 60 is divisible by what? Divisible by what? X is a prime number. Do you know about the definition of a prime number? First we shall discuss the definition of prime number. So what is meant by prime number? Let us consider. We are discussing the definition of prime number. For example, P is a number. First condition, it should be greater than 1. Next condition, number 2. P is divisible by 1 and itself only. For example, P should be greater than 1. Remember, it should be greater than 1. Don't say 1. Don't take 1. So we will start with the number 2. Okay, 2. First condition. Is it greater than 1? Yes. Next condition. 2 is divisible by 1. Yes. Divisible by means what? 2 divided by 1. 1 2s are 2. Remainder 0. This is called remainder. When in division algorithm, if we are getting 0 remainder, then clearly we can say that 2 is divisible by 1. Since the remainder is 0, we can say that 2 is divisible by 1. Okay, and means what? This condition is satisfied. Last condition, it is divisible by itself only. Means 2 is divisible by itself means 2. 2 is divisible by 2. Okay, so 2 is greater than 1. 2 is divisible by 1 and itself 2 only. Means 2 is not divisible by any other number. For example, let us take 4. First condition. Of course, 4 is greater than 1. This condition is satisfied. 4 is divisible by 1. Okay, it is satisfied. 4 is divisible by itself means 4. Okay, this condition is satisfied. But 4 is divisible by other number 2. How? 4. Let us take 4 divided by 2. 2 2s are 4. Remainder 0. So therefore 4 is divisible by other number. Therefore 4 is not a prime number. Prime number. Next 3. Let us take 3. 3. Of course it is greater than 1. 3 is divisible by 1 and 3 is divisible by 3 means itself only. 3 is not divisible by any other number. Therefore 3 is a prime number. But 4 is not a prime number. Next consider 5. 5 is greater than 1. First condition over. 5 is divisible by 1. Second condition over. 5 is divisible by itself means 5. Okay. And 5 is not divisible by any other number. Next, last example. 6. Let us take the number 6. Let us take the number 6. So, first condition, 6 is greater than 1. Okay. 6 is divisible by 1. Okay. 6 is divisible by itself. Itself means 6. Is it over? No. 6 is divisible by other number 2 and other number 3. 3 2 is 6. 2 3 is 6. So therefore, according to this condition, it is failed. Means 6 is not a prime number. So let us list out some prime numbers. 2 is a prime number. 3 prime number. 5 prime number. 6 is not a prime number. 7. 9. 9 means 9 is greater than 1. 9 is divisible by itself. Okay. 9 is divisible by 1. Okay. But 9 is divisible by other number 3. Therefore, 9 is not a prime number. Similarly, 10 also. 10 is divisible by other numbers 2, 5. Next, 11. Like that. 13, 14, 15, 16, 17, 19, just like that. These are all prime numbers. Of course, infinite prime numbers are there in the number theory. Okay, now come to the question. Divisors of 60. Actually, 60 is divisible by 1, 2, 3, 4. 4 into 15. 60. Barobar. Next, 5. 5 into 12. Means it is divisible by 5. 5, 6, 7, 8, 9, 10, 12. 12. It is divisible by 12. 13, 14, 15. 16, 17, 18, 19, 20. It is divisible by 20. 20, 21, 22, 23, 24, 5, 6, 7, 8, 9, 30. It is divisible by 30. Next up to 39, 40, no, 45, 50, 60. Last number 60. 60 is divisible by 60, just like that. Okay. 60 is divisible by all those numbers. Out of which one is prime number? Which one is prime number? Already I said 1 is not a prime number. 2 prime number. 3 prime number. 5 prime number. Remaining 6 is not a prime number. 10 is not a prime number. Because it is divisible by other number 2 and 5. Next 12, it is not a prime number. It is divisible by 2, 4, 3 other numbers. 15, it is divisible by other number 3, 5. It is divisible by 10. It is divisible by 4. It is divisible by other number 5. So it is not a prime number. It is not a prime number. So it is not a prime number, not a prime, 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 not a prime number, not a prime number. Out of which 2, 3, 5 only. So therefore, number 4, capital D is equal to the set of 2 is a prime number and 2 is divisor of 60. 3 is a prime number, it is divisor of 60, and 5 is a prime number, it is divisor of 60. Out of all divisors of 60. So first we have to find up to 60 which numbers are divisors of 60, or 60 is divisible by, take the list of the numbers, out of which find out the prime number. So therefore, out of which only 3 are the prime numbers. Next, question number 5. Number 5. The set of only letters, just you write all the letters from the word trigonometry. So trigonometry. So therefore, say capital E. Capital E is equal to the set of first letter T. 1 minute. T 2 times are there. So in roster form, repetition not necessary, order not necessary. It is immaterial. So therefore T. Okay. Next R 2 times are there. It is enough to write only 1 time. And the order is not necessary. First you can write R. Next you can write T. Just like that. Next I. How many I's are there? Only 1. So therefore I. Next Z. How many G's are there? It is out of question. How many O's are there? 2. Instead of 2, it is enough to write single time. O. Next N. N. Next M. M. Next E. E. Next is what? Y. So how many times are there? It is not criteria. Therefore, just you write only single time and you need not to follow the order. Similarly, you can write it as R, capital E is equal to the set of, you can change the order. N, you can write first N, next R, next I, next T, next Z, next M, next O, next Y, next E, just like that. You can change the order as you wish. So therefore, in roster form, order not necessary and repetition of the letters or objects of or members or elements not necessary. Hence the problem.